All right, folks, welcome to our continuing discussion of the fundamentals of statistics. We've talked a little bit about some basic terminology in statistics, different categories, different forms of measurement, those scales that we've talked about. As always, there are some practice problems on those in our practice problem section and in the assigned homework. But today we are going to talk about the very first thing we're going to do with that data, some basic things we can do to organize it and make sense of it. So, first, again, when you complete a study, again, you have some kind of a variable that you measured. Maybe it's a DV, maybe it's not an experiment and it's just a measured variable. And again, you wind up with generally a pile of numbers. If it's a nominal variable, it's like a pile of categories. But you wind up with just a great big jumble of scores on whatever variable you happen to have measured. This is called raw data. So oftentimes we start with the raw data and we start the work of organizing it and interpreting it right away. That's somewhat commonplace. However, in a lot of instances, we also might want to do what's called a transformation of our data. When we transform data, we alter it in a way that is designed to make it more workable or more consistent. So we might convert it into a common form, like for example, if we got weather readings across the country, we would have temperatures in Celsius, temperatures in Fahrenheit. We don't want to lump those together. We would just convert them all into the same scale so that we could work with them. We are going to be learning some basic transformations a little later on. If you look ahead in the syllabus, what's called z-scores is a very basic way of transforming things that has some advantages. But basically, the first step when analyzing data is to take your raw data and figure out if you need to transform it or not. Either way, at some point, you're going to wind up with data that is usable, whether you needed to transform it or not. The very first thing we do with that usable data, or one of the simplest things we can do with it, is to organize it, to make it a little bit clearer so that trends and tendencies in the data set emerge. So this involves simple visual organization. About the most basic thing we can do to organize information is to put it in a form that's easier to visually digest. That generally means either making a table or making a graph. We're going to learn about some common forms of both of those, but today we're going to focus on the tables. So again, raw data, we have a pile of numbers. It's hard to make sense of. Here we see a really small data set. We asked 20 homeowners how many cars they own, and we can see the scores here all in a row. Even with just 20 scores there, it's still hard to pick out consistent trends. We can see some basic stuff there, but we don't have much of a sense of how relatively common different scores are. We can tell which ones are a little more or less common, but it's very hard to pin down real patterns in that data. So one of the most basic things we could do to organize it, to find overall tendencies, is to build what's called a distribution. Distributions, put a big star next to distribution if you're taking notes. They are key, vital concepts for basically the remainder of the course. We're going to be working heavily with distributions, like almost every single day. So a distribution is a way of organizing scores to see which scores are more or less common in what's called a frequency distribution. So the most common distributions, really the only ones we'll be working with in this class, organize scores by frequency. You organize your scores from lowest to highest, and then you represent how common or uncommon, how frequent or infrequent each score is. Here's the simplest type of common frequency distribution. So it's called a frequency table. A frequency table is a table. It's a series of rows and columns that tell you which scores are in the data set and how often each one occurred. So here's how we make a frequency table by hand. First, we take each value that we find in the data, each one that's actually represented as a score, and we order it from the highest on the top to the lowest on the bottom. We only cover the scores that are present in the actual data set. Then we go through the raw scores and we make a mark next to each one of those scores next to the row that represents that specific value. So we do that one at a time. Each score, if it falls, if someone owns 2 cars, you make a little tick next to the mark number 2. You do that for every single one, every score that you've got. Then we convert all those little tick marks to raw numbers, just to make it easier to make sense of. Finally, we do a little bit of standardization, and this is actually a form of transformation. We want to standardize it because different data sets have wildly different numbers of scores. We standardize it by expressing it as a percentage. We take the total number of scores that have a specific value, we divide it by the total number of scores in the data set, and that shows what's called relative frequency. What percentage of the total data set fell under this value? So let's see what that looks like with our car data set here. Again, we have 20 scores there. We look through it. We're going to look at all the values found in the data. We say, okay, obviously it's not possible to own fewer than 0 cars, and nobody in the data set has more than 4. So we would make scores from 4 to 0. By the way, a little callback to our scales material. Think about what sort of scale is this measurement, the number of cars that people own. Is it nominal, ordinal, interval, or ratio? Pause. It's a ratio scale. It is impossible to own fewer than 0 cars, and that reflects a total absence of car ownership. Owning 4 cars is twice as much as 2 cars. Is it a discrete or a continuous scale? Pause. It's a discrete scale. Everybody owns cars in whole numbers. You own no cars, 1 car, 2 cars, 3 cars. We're not talking in terms of car ownership about owning 3.42 cars. That could be true on average, but each individual homeowner is going to own a whole number of cars, so that would be a discrete variable. Back to the frequency table, we have a row for each one of our values for the number of cars that are owned. Now we go through for each car, we tick it off. This one's a 1, so we make a tick mark next to the 1. The next one's a 2, we make a tick mark there. We do it for all 20 scores. And again, you can count those up to make sure they add to 20. Then we just convert them to whole numbers just for simplicity's sake. And then finally, we calculate the percentage of each value. There are 2 people that own 4 cars in our data set. There's 20 total people. 2 divided by 20, 10% of our data set has a score of 4 cars. 15%, 3, so on and so forth. This standardizes it so we now can, again, have a nice consistent way of assessing how relatively common each score happens to be. So that's a normal frequency table. Once in a while, and we're not really going to do this by hand, there are a lot of unique scores. There's too many to make a real frequency table. If you had a data set where there were like 100 different unique values that are represented in the data set, you'd have to make a frequency table with 100 rows. That defeats the purpose of making it easier to make sense of, making it digest. What we might do in that case is build what's called a grouped frequency table. With a grouped frequency table, it's still all organized the same way, but each row, instead of being a single value or score, is an interval, a range of scores. So which interval size you choose depends on the actual nature of the data, but generally we pick things that are round numbers or multiples of 5, and we usually want to be able to fit all of our data into relatively few categories. 6 to 10 different categories is a decent rule of thumb. That's usually right around the sweet spot for giving as much information while still being very digestible. So for example, once upon a time I asked 47 students in a social psychology class to count how many seconds they thought had passed while I timed out exactly 1 minute. Couldn't look at their phones or clocks or anything. Look at this big pile of numbers. It's real hard to pick out consistent patterns there at all. There's a lot going on, and there's a lot of different values there in the data set, which means a regular frequency table would need lots and lots of different rows. Instead, we're going to create a grouped frequency table. We're going to make each row intervals of 10. How many people estimated between 90 and 99 seconds? How many between 80 and 89? 70 and 79, so on. Here we see our frequencies calculated the same way. The percentage calculated the same way. It seems to be misformatted a little bit. But again, we can pick out trends in this much bigger and more complicated data set very quickly as well. We can see most people estimated between 50 and 69 seconds. We can see that people were more likely to overestimate how much time had passed than underestimate how much time had passed. Again, little nuggets of information that are really, really hard to pick out if we're just looking at the entire data set here. So that's the end of our discussion of frequency tables. There are examples of making them in the book and in the homework, and I believe in some of our practice problems as well. Again, the important thing isn't making this stuff by hand, because nobody really does that. You might have to do that in this class, but that's not the important part. The important part is understanding how it's used to summarize information, to organize it in a way that makes it easier to make sense of trends in the data and identify them. All right, next up we'll talk about an even more kind of digestible form of doing exactly that, making graphs of different amounts of frequency. See you there.